Hi guys, this is the video notes for solving systems of equations. This is topic 2, our second method of solving a system, substitution. So when we look to use substitution, this is completely algebraically. We do not need to graph these two lines in order to figure out where their solution is. So the way we do this is we look for a variable that's isolated by itself on one side of the equal sign. So in this case, we have y by itself on the left side of the equal sign in that second equation. So once we have this, or find this equation, we can take what y is equal to, and I like to put a little rectangle around it. So if y is equal to 3 plus x, we can substitute that expression in for y in the other equation. When we do this, we can then reduce it down to only one variable, and that's something we can solve. So I got a little ahead of myself. Let's rewrite that first equation, but instead of writing y, we're going to do a big set of open parentheses. So I rewrote that first equation, but instead of writing y, I have open parentheses, and then I'm going to plug in that boxed expression. Since y is equal to 3 plus x, I can then substitute it in for y to then solve the equation. So now I have an equation with just one variable, something we can definitely solve. So I notice I have two like terms, x and x combined to 2x. And now we solve this equation. Subtract 3 from both sides, divide both sides by 2. So now we have our x value, but if you remember back to graphing, we need an x and a y value. We have two variables that we don't know, so we need to solve for both of them. The good news is once we have one, we have the other, we just need to plug it back in. So if we look back at that boxed equation, y equals 3 plus x, we can rewrite it, but now we know x, so we replace the x with positive 1, because we solved and got x is equal to 1, therefore y has to be 4. The only thing left to do is make sure we write our answer in an ordered pair, x comma y, so we have 1 comma 4. And you can always check your work by plugging in 1 for x and 4 for y into both equations to make sure they are true. Let's take a look at another example. So our second example, again, with first thing we need to do is find a variable by itself on one side of the equal sign. Now we have that in both equations. So when we have y by itself in both equations, you're just going to set them equal to each other. So take 3x plus 4 and set it equal to negative 1/2 x minus 3. Again, there's only one variable now, and this is an equation we can solve. We did this the very, I think, first unit, of school. So let's get our x's to the left, and we'll get our regular numbers to the right. So 3 plus 1/2 x gives me 3.5 x, negative 3 minus 4, negative 7. When we divide both sides by 3.5, we get x is equal to negative 2. So now we can choose. We can plug it into the first equation or the second equation. It does not matter what you plug it in for as long as we plug it in for x. So I'm going to use the first equation just because there's no fraction. So I now know that x is equal to negative 2. So I'm going to plug it in for x. Multiply and combine. So x and y are both equal to negative 2. Write it as an ordered pair. All right, taking a look at example 3, I see x by itself on one side of the equal sign. So I'm going to put a box around what it's equal to and draw an arrow to where I'm going to substitute it in. So if it's equal to x, I have to plug it in for x. So I'm going to rewrite that second equation, but instead of writing an x, I'm going to do a big set of open parentheses and continue finishing that equation. So now I can replace the x with that boxed expression, negative 3y plus 7. For this problem, unlike the last two, I do have to use the distributive property and then combine my like terms before I can actually solve this equation. So now I'm going to subtract 28 from both sides and then divide both sides by negative 14. So now that I have one variable, I'm going to plug it in. Again, using that boxed equation, x equals negative 3y plus 7 is going to be the easiest, but we now know that y is equal to 2. So multiply and add. We get x is equal to positive 1. So be really, really careful because in the previous two problems, we solved for x first and y second. We still need to make sure when we write our ordered pair, we write x first and y second. So x is 1, y is 2, so it's 1 comma 2. A big mistake that I see a lot of times is we just write it in the order that we do it, which would be incorrect. All right, so we have two more examples and they are going to end up being short. So these are our special cases. So if we remember back to graphing, we had infinitely many solutions and we had no solutions. So if you can guess, we're going to have one of each in example 3 and example 4. So if we look at the first one, we have y by itself. So we're going to box what it's equal to and draw an arrow to where it's going to substitute. So if it's equal to y, we have to replace the y. So rewrite the second equation, 4x plus 2, use big parentheses for y equals 8, and substitute in that boxed expression. So we got to simplify this left side before we can solve. So 4x, bring it down. We need to distribute that positive 2. So that will give us negative 4x plus 8. And when we go to combine like terms, 4x and negative 4x cancel each other out, and we're left with 8 equals 8, which is a true statement. So this is IMS, which stands for infinitely many solutions. So if we're left with something true, we say IMS. Example number 4, again, we need to find the isolated variable. So x is by itself in that first equation. So box what it's equal to. And if it's equal to x in the first equation, it's equal to x in the second equation. So rewrite the second equation, but use big parentheses for x. So big parentheses plus y equals 7. Substitute in that boxed expression. Now this time, when we combine like terms, just like the previous example, they cancel each other out, but we're left with 3 equals 7, which is a false statement. So that means our answer is no solution. All right, you guys have 3 U-tries, so do these on your own, and you can check in a Zoom meeting or via email your solutions. Thank you for listening.